Hey boys and girls, welcome back to another edition of Think Different Television. All right, so we're doing dilations, but instead of dilating image, we're either enlarging it or reducing it, either stretching or shrinking it, we are now going to see what the scale factor was to begin with. So now we're given the image and the pre-image in all of these, and we're going to figure out what happened. Did it enlarge, did it shrink, and by how much? Well, this is what we do. So this is the first thing. To determine the scale factor, that's what we have to do. For the dilation of XY, line segment XY to line segment AB, determine whether the dilation is an enlargement, reduction, or congruence transformation. Okay, important. Scale factor equals image length over pre-image length. That's what we're going to do. And C is the point of dilation right there. And C is going to be the origin, since that's the only thing we know so far about the point of dilation. So what I did is this. So copy down this for the notes. So we're determining the scale factor for today. And for C, I just put it as the origin. So that's the only difference between that picture and this picture. And the scale factor is the image length over the pre-image length, or Y prime over Y. So there's two ways to do it. And I'm going to show you both ways. Whatever you're comfortable with, use it, whatever. All right, check it out. So we're going from XY to AB. So we're going XY to AB. So obviously this is an enlargement, since this is the pre-image. And AB is the image. Always good to write stuff like that to make sure you know which is which, and it helps you with this and this. So one thing you can do is find the length. So you can find the length of any side. So this is easy to tell. So the scale factor, write this down, equals the image length. So the image is AB. So the last thing, or the bigger thing, or the smaller thing. So the image is 1, 2, 3, 4, 5, 6, 7, 8 spaces. Bam. And the pre-image length is your denominator, so that's going to be XY, so that's 1, 2, 3, 4. So 8 divided by 4 is 2, so the scale factor is 2, so you can say R equals 2, or K equals 2, depending on what it uses for scale factor. So that makes sense because this AB is twice as big, from 4 to 8. Another way to do it, if you don't want to count like that, I just do the Y prime over Y. This is a way to do it. So you don't worry about the X coordinate, just worry about the Y coordinate. So like here, the X coordinate, so I'll do it over here, I got room here. So scale factor. So the Y coordinate of X, that's 1, 2, right? But so that's the pre-image, so that goes here. And this Y coordinate of the image right here goes 1, 2, 3, 4. So the image Y coordinate is 4. The pre-image is 2. 4 divided by 2 is also 2. Ding, 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 ding. So that works. So you can use the Y coordinates if you want, or you can use the image length. You'll get the same thing. All right, let's try another one. Example 2. Here is, in your PDF, it should look something like this. Number 1, like this. So copy this down. Oh, I forgot to say this is an enlargement here in the first one. Sorry. There you go. So you copy this down. So I put C as the center of the rotation as the origin. So I created an XY chart for myself. That generally helps. So that's the only difference I had from the last problem. So here we go. So scale factor, we're going to do it both ways. You decide which way is best for you. Or you can do it both ways. So that's going to be the image over pre-image length, or the Y coordinate of the image over the Y. So Y prime over Y. So let's do image over pre-image first. It doesn't matter. But which is which? It tells me. Okay. So it says in the problem, CGHJ is the dilation image of CDEF. So CGHJ is the image of that. So this is image. So CG, so the big thing is the image. So this is the image. And dilation of CDEF, so this is the pre-image here. I always write this to make sure I don't mess it up. Sometimes I forget when I'm doing all this. You got to be precise, because if you reverse it, you're going to get it wrong, and you don't want that because this is easy. Okay, so you count the length. So one thing is the length of the image. So I can choose any side. This side, this side, this side. It's all the same. So it's all similar. So I don't know, let's do the top. 1, 2, 3, 4, 5, 6, 7, 8. Boom. And the pre-image length, so same relative side. So I'm counting this side, so I'm going to count this side. If I did this side, I would do this side right here. So 1, 2, 3, 4. 8 divided by 4 is 2. So it's twice as big. So it's an enlargement. R equals 2. Enlargement. Nice. Okay. So let's do this one. Y prime over Y. So Y prime is the image. So let's choose this one. This one is 1, 2, 3, 4, 5, 6, 7, 8. And the Y in the same relative position would be C. That's 1, 2, 3, 4. Oh, same thing. There you go. So when I count the Y over this, or this, same thing. If I count the Y to G and D, I get the same thing, because this is 8 for G, the image, and then this is 4. 8 divided by 4 is 2. So it doesn't matter what pair I choose, as long as they're in the same relative place. So these two, or these two, or these two. Cool. All right, let's do another. Example 3. This one's fun. Look at this. Woo! Yeah. Check it out. So I'm doing number 3 right here. Number 3 right here. Copy it down, copy it down. The only thing I'm doing is I'm putting C as the origin, because that's how we know how to dilate about that point. So the only thing I did was I put C as the origin. Okay. STUVWX is the dilation image of MNOPQR. All right. So STUVX. So this 1, 2, 3, 4, 5, 6. This hexagon here is the image. So this inside is the image. And that would mean that the bigger one, the outside, is the pre-image. Based upon what it just told me. It says STUVX. So VWX is the image. So that means this is the image. So that means the other one has to be the pre-image. Okay, scale factor. That's the image over the pre-image, or Y prime over Y. Either one's going to work. I don't have to do both, but I'm just going to do both to show you. All right, so it's image over pre-image. So I can choose this and this, right, for length, but I would have to use the Pythagorean theorem or distance formula, so I'm not going to use these two sides or these two sides, which are corresponding. I'm going to use this, because this is straight. It's easy to count when it's straight, right, on the coordinate plane. So image is the inside. So this is going to be, this is a half, by the way. Oh, well, that's kind of hard to do. I don't like that. Let's count the middle. So is that a half? Is that a third? I don't know where that is exactly. So maybe that's not smart. I just realized that. So let's do this, because I know this distance here, so I can cut it in half. Check it out. So 1, 2, 3, 4 across the middle. So that's 4 across the middle. Now here, R to O, that's the middle of this. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8. So the pre-image is 8 across the middle. Yeah, you can do that. I could also do this and this, but I don't know. Is that a half? Is that a third? Unless it tells me a fourth, I really can't tell exactly where that is. So I'm just going to use what I know, and where it touches the axis, that's what I'm going to use. So 4 over 8 simplified is a half. Yeah, it shrunk. It went from the pre-image to the image. So it went whoop like that. So it shrunk down. Maybe the y prime over y is a little bit easier here. Let's try it. So scale factor. So I'm not going to use these because these, I don't know exactly what that is, but I can use, what can I use? You can use this and this. Oh, I can't use it. So that, actually this problem doesn't really work with the y's since I really can't tell in this one necessarily. So I had to do the image and pre-image. That's the one that works, and good thing I have that. So you may want to have both strategies because both could be at play. You could use one and not the other, like in this problem, which is a half, and this is a reduction. Cool. All right, now you try these two right here. Last two. So you're going to do 4 and 5. 4 and 5. Ready, set, go.